Hello and welcome to the introduction to AndEngine. This is just going to be a brief video and there's not going to be any programming involved. It's more of an overview. So if you want to skip straight to programming, go to the next video where we set up a basic AndEngine game. AndEngine is an OpenGL 2D game engine that was developed by a person named Nicholas Gramlich. And a number of Android games are actually powered by AndEngine because it takes the labor out of developing the OpenGL backbone that powers advanced games and makes advanced graphics possible. And so a lot of people ask, what can AndEngine do? And a better way to answer that question is to tell you what AndEngine can't do. And the only thing it really doesn't do is to provide 3D graphics. AndEngine is strictly a 2D game engine. Beyond that limitation, it's really going to take care of all of the behind-the-scenes OpenGL work, and that includes rendering scenes, handling the game loop, drawing sprites, dealing with sound, and making that connection between the game that you program and the basic underlying Android operating system. So it really takes the legwork out of all of that. Some people think that using AndEngine is kind of a way of cheating because you're not developing all of the aspects of the game yourself. And it's true that some of the larger studios do develop their own engines. However, they don't all do that. A lot of them lease engines from other people. And what's more, they don't develop a new engine for every game. They reuse engines because they're time-consuming to create. Carl Sagan once said, if you want to make an apple pie from scratch, you must first invent the universe. And I think that's a useful quote for thinking about programming. You don't really need to do anything from scratch other than create your game. The idea that you have to build your own game engine is kind of along the same lines as saying, well, you need to code your own integrated development environment. And to do that, you have to develop your own computer language. And before you can do that, you need to build your own computer. And before you do that, you need to build and manufacture all of the components for that computer. It's a silly argument. Modern society works by leveraging what other people have done. And that's what we're going to do. We're going to leverage Nicholas's excellent work so that we can simply develop games and not worry about the nuts and bolts of OpenGL. And so that brings us to the important concepts when dealing with AndEngine. And there's just a couple of them. The first important concept we need to understand is the camera. The camera controls what the player views. And the best way to think about this is like you're shooting a movie. The camera controls things like zoom, it controls panning, and it can even be set up to programmatically follow a specific sprite or character in your game. One of the difficulties in dealing with Android game programming is the fact that the camera will need to be custom set to deal with all of the different screen sizes and screen densities that Android offers. It's a little different than dealing with the iPhone, which basically has, 3 screen sizes. You can do iPhone, iPad, or iPad mini. So it gets a little bit more complicated, and we'll go over how to deal with that. The next concept we need to worry about with AndEngine is scenes. Scenes are really the background for all of the action that takes place in a game. scenes will contain things like background graphics, sprites, text that tells you things like score, and so forth. Scenes are what the camera is offering us a view of, and you can actually have multiple scenes in a game if you want. And the way you handle their scenes and their transitions is what determines whether your game is compelling or not. Now, scenes are made up of layers. And the best way to think about a layer is think of a top-down game where you have a bird's eye view of what's going on, kind of like Legend of Zelda. The bottom layer is the background, the grass and all that kind of stuff. The next layer up, as if you're floating up from the ground toward the sky, would be the kind of middle ground where most of the action takes place, where sprites interact, and so forth. And then the top layer acts like the foreground, so it might be clouds, or if you're playing like a platform game, it's like trees that appear in front of the character. And the concept that you really need to keep in mind with layers is that lower layers are always rendered first, which means that subsequent layers will be drawn on top of them. Understanding layers is important because it determines the order in which your sprites are drawn. And sprites are the next concept that we're going to cover here. But before we do that, we need to understand what an entity is. And so really, this bullet point is going to be entities and sprites. In AndEngine, an entity is anything drawn to the screen. So technically speaking, layers are entities, scenes are entities, sprites are entities, text is an entity, so on and so forth. Anything the game draws is an entity. Sound would not be an entity. So a sprite is an entity. But a sprite is more than that. A sprite is really an object, like a player, or an enemy, or something that the person playing the game is going to interact with. So if you have background that they can interact with, that's really a sprite. Trees that the player can run into, also a sprite. And in AndEngine, we're going to worry about two basic kinds of sprite. There's your kind of static sprite, which is just a single image. And then there's your tiled sprite. And a tiled sprite you can think of like a film strip of individual separate images that you can run together to create an animation and give the illusion of movement and action, or that you can use to change the way your sprite looks under different circumstances. So if the first frame of your tiled sprite is a smile, and the second frame is a frown, when something bad happens to your character, you can switch your sprite from tile 1 to tile 2. That's a very simple way of changing the appearance of your sprite without having to go through a lot of programming. The next thing we're going to worry about in terms of AndEngine concepts is textures and texture regions. Now, a texture is when we talk about sprites, we tend to think of them as things like a person or a frog or whatever your game happens to be. But actually, a sprite is just a box or a circle. To make that sprite look like something, we add texture to it. And texture is usually a bitmap, or some form of a bitmap, like a JPEG or a PNG. You'll see with AndEngine that PNG graphics are kind of the basic go-to graphic, but it also supports vector images. So we take a texture, we add it to a sprite, and that's what gives us our game graphics. And the complexity of a sprite determines, kind of how your game looks. Now, a texture region is just kind of the memory area that OpenGL is going to set aside to hold your images. So, the memory can range from 32 bits in AndEngine all the way up to kind of an undefined number. But there are a couple of rules we need to keep in mind. They always have to be a multiple of 2. So you can have a 32-bit texture region, a 64-bit texture region, a 128-bit texture region, and so on. But you can't have a 100-bit texture region. It's just the way AndEngine is set up. The other thing we need to keep in mind is that, practically speaking, 2048 is the largest your texture should ever be. Anything beyond that, and you start to incur some performance penalties. I prefer to stick to texture regions that are 1024 or smaller, but there is the occasion where you want to go all the way up to 2048. Now, everything we've just discussed is controlled by the engine, and if I could spell it right, it would probably help. And the engine is really the intermediary between your game and the Android operating system. It's also going to control the game loop, and a lot of game programming focuses on the game loop, but we're not going to worry about this because that's more of a programming endeavor, and we're interested in the creative aspect of game programming, getting our game out there, and not worrying about all of the subtle details that go into dealing with the nuts and bolts of a game. So the engine's going to handle the game loop. It's going to handle drawing. It's going to handle user input. And it's going to handle other things like sound, text, and so forth. Now, there's one thing we want to keep in mind about an engine. The faster an engine runs, the smoother your graphics look. And we want to keep in mind that 60 frames per second is the target for most games. Now, you're not always going to be able to sustain 60 frames per second because the hardware you're dealing with may not be able to handle it. You may be interested in higher resolution graphics, so on and so forth. So for most high action games, you want to keep in mind that 30 frames per second is your bare minimum. Anything below that, and the human eye is able to detect the transitions, and things start to look choppy. So if you want the illusion of smooth movement, never drop below 30 frames per second. Now, of course, if you're building a game like chess or checkers, frame rate's less important. It's really these action games, side-scroller games, anywhere where you want movement to look smooth and fluid, that frame rate's going to be important. Now, the last concept I want to talk about in AndEngine is physics. And physics is handled by another engine called Box2D. Box2D was developed by some other programmers, and it's actually pretty widely used. A lot of iOS games use it, a lot of internet games use it, and most Android games use Box2D. So Box2D is a physics engine. It simulates how your sprites would behave under the effects of things like gravity, collisions, joints, friction, and a whole lot more. So you can simulate all of the things that are involved in kind of classical Newtonian physics using Box 2D. Now the engine's a little bit tricky to understand at first because you have to convert scene measurements into meters per second and other metric measurements, because Box 2D does all of its simulation using metric measurements. But we'll explain how to work through that when we get to that point. What's really critical to understand about Box 2D is that it's an engine. An AndEngine is, of course, an engine. And the two need to be connected. And so that's handled through things called physics connectors. So here's how the scenario works. If I want to make a sprite work under Box 2D, I have to use a physics connector to connect that sprite to the Box 2D world. So here's how, this is kind of the scenario, the rundown of how a game that uses physics would work. First off, Box 2D will simulate physics for what it calls bodies. And a body can be any convex shape. Now that's important, it has to be convex. But we'll worry about the details of that later. So Box 2D is going to simulate the physics for every body that you tell it to. And it's going to say, how does friction affect this body? How does gravity affect this body? So on and so forth. Then it will find the physics connector. And it will say, I've simulated how this body will move. Now I need to tell AndEngine how it has changed. So the physics connector carries Box 2D information to AndEngine. AndEngine then uses that information to tell OpenGL how to render the scene. In other words, how to draw. And it's as simple as that. Those are the basic concepts that everyone needs to know in order to use AndEngine to develop Android games. The next lecture is going to show us how to dive right in and develop simple how to develop the framework for an AndEngine game. And it's just going to be very basic. So I hope you'll look for that video.